Hello students, this is our tutorial home, and I am continue discussing our analytic geometry and second two-dimensional analytic geometry, and the topic is straight line. So this is the second video, second part of the straight line topic. Second part, first part already uh, closed, and that's why the remaining part is lost now. So let's start. Uh, I have shown that already in the first gallery video that for in a Cartesian plane for any straight line which intersects y-axis, then its general equation is, if we know the tendency is m, which is the tangent of the theta, tangent of the angle between the straight line and the x-axis. If this is theta, then the tendency will be m is equal to tan theta, and the equation will be, and one more thing you will have to know, that the intersect point on the y-axis. So if this is 0 c, the distance from the x-axis is p of the straight line on y-axis, then the general equation will be y is equal to, of the straight line, y is equal to mx plus c. And one more form I have already discussed. I want to remember all of it. That's why I am again rewriting it. If the straight line passes through both axes, x-axis and y-axis, I am taking the first quadrant to make it easier. And the intersecting points are A0 and 0B, E0 and 0B. Now what will be the equation of the straight line? You can use this general form also, but to use the intersect point, it will be much easier to calculate the equation of the straight line. That's why this is the form. This is x by a plus y by b is equal to 1. This is another form of the straight line. Both are same, but this is used mainly if you know the intersecting point, then use this. And if you know the tendency and the intersecting point on x-axis, then use this equation. Now I am introducing a new form of the equation. Take a Cartesian plan in this way. This is the Cartesian plan. Here it is x-axis and this is y-axis. This is y-axis. Now any straight line passes through both the axes and it has an intersecting point, but we do not want to use the intersecting points. We want to use the distance from the origin of the straight line. This is, let's say it is p. This is p. Then we want to use p and the distance, because since this is a perpendicular from the origin to the straight line, since this is a distance, so the angles must be pi by 2, 90 degree. So both are 90 degrees, pi by 2 angles. So now I want to use this distance to formulate the equation of the straight line and the angle made by p and x-axis. The distance and the x-axis between the angle is between both of the angle is theta. So we want to know, we used to formulate the equation of the straight line using just p and theta. How can we use this? Now if this is theta, this must be pi by 2 minus theta. This will be this must be pi by 2 minus theta. Then what will be the angle this? What will be the angle this? This must be theta. See, this is pi by 2. This must be theta. Now, what will be the angle here? If this is pi by 2, this is theta, then this must be pi by 2 minus theta. This must be pi by 2 minus theta. Now, to use p and theta, we just use the intersecting point to calculate the equation more easily. I am taking a0 for the first the intersecting point on the x-axis between the straight line and the x-axis, and this is I am taking 0b, intersecting point between the straight line and y-axis. Now we know in this form of the straight line, using the intersecting point, that this will be x by a. We have already proved this will be x by a plus y by b is equal to 1. Now we wish to know the value of a with respect to the value p and theta, and b just using the value of p and theta. So we will express a and b by using p and theta. So both are right angles. O, if you take it a, this is b, and this is c, then you can very easily look that OBC and OBA both are right triangles. This is the perpendicular on the straight line. So now A by since this is theta, so in this with this respect to the angle, P by A will be its base, and A will be its hypotenuse. So base by hypotenuse equal to cos theta. So we can now find out A by using this. So here A will be P by cos theta. Now we wish to know B. So since OBC also a right angle, so here if we will take this theta, then this is the base and this will be the hypotenuse. This will be with respect to this angle theta, this will be the perpendicular, and this will be P is the perpendicular, and B OC is the hypotenuse. So P by OC means B equal to sin theta, perpendicular by hypotenuse, sin theta. Now here we are getting B is equal to P by sin theta. We'll replace both the value of A and B in the intersecting form. So we'll get here, replacing this, very easily you can say that x cos theta plus y sin theta is equal to P. This is the form, just using the distance and the angle between the distance and the x-axis. This is very important form. If you given of any straight line, the distance from the origin or from any point, it can be also evaluated from any point also, just using transforming the point to origin. You can evaluate from any point to the straight line, and the distance and the angle between the distance and the straight line. You can very easily evaluate this form of this equation on the straight line. So very important. Now I am using some senior topic. Take another look. Now we want to know the equation of the pair of straight lines. Any in any Cartesian plan, if we have two equations, two straight lines, then what what kind of what we use to evaluate the equation of the both of the straight line, means we wish to evaluate such a equation that shows both the straight lines, that expresses the both the straight lines. So now take the straight lines, both the straight lines are AB and CD. So now two straight lines here. So one straight line equation is general equation is uh, AX plus BY. This is more general equation. I have already used a general equation with using tendency. You can evaluate the tendency by just expressing y with the help of x, and then you get the tendency, also the intersecting point C. This is the more general form. So I am giving that this is a1x, b1y, and c1 for AB. This equation expresses the straight line equation, AB's equation. And another equation, a2x plus b2y plus c2. This is expressing the another straight line equation. But both equations showing just single straight line. No more, not more, both the equation, both the straight lines. So we multiply both the equation on left hand side and right hand side. Then we will get a1x plus b1y plus c1 and a2x plus b2y plus c2 is equal to 0. If you consider this is a single equation, then any point on straight line AB and any point on the straight line CD satisfies this equation. Any point, since this is also 0, this is also 0. So any point on AB satisfies this equation also, and any point in this straight line CD satisfies this equation. So this equation, if you take a single equation, then represents both the straight lines. So this is the equation of a pair of straight lines. You can also represent three straight line, just multiplying three equations, n times of straight lines by multiplying n times of equation just. So this is a very general form of pair or pair of straight lines or more than pair of straight lines. So this is this is the general form of the equation of pair of straight lines. Now look this, a general form of equation we will obtain just multiplying we in earlier I have already shown that just multiplying two two linear equations of two variables, of course, two variables linear equations on x in x and y, multiplying them and those we will get ax square plus in this form 2h xy plus by square. If both the equation passes through the origin, then we will get in this form of the general form of the pair of straight lines. Just multiply both the equation, but here the condition is that both the straight lines must go through the origin. Both the equation must go through the origin. Here, both the equation passes through the origin. So here we wish to know what will be the here we can look that if we'll take this is equation on on just x, then this is a quadratic equation on x. So from this we'll get x equal to Acharya Sutra. The roots will be minus b 2h y plus minus root over b square. B square will be 4 h square y square minus writing below into 4 a b y square in such a form, the discriminant, and in below the denominator will be just 2a. So this will be the roots with respect to taking the equation, general equation in the quadratic form of x. Now if the discriminant will be greater than equal to 0, then if the discriminant will be greater than equal to then the roots will be real and positive, and if this is less than 0, then the roots will be complex. So we must need the discriminant must be greater than equal to 0. So from this we are getting 4h square y square minus 4 ab y square is equal to greater than equal to 0. So if this happens, then we will have the x points are real and positive. So from this we are getting that y square equal to 4h square minus 4ab greater than equal to 0. 4 will cancel. If y is the if we do not take and the general point on both the straight line, the origin, then y is not equal to 0. Then we will get, if y not equal to 0, y not equal to 0 means the point we are considering is not origin, then we will get h square is equal to h square greater than equal to ab. This is the condition that we are getting real and positive roots of xy. Now this can also true if we take uh, the quadratic form of y, and we will get the same condition, and h square necessarily be greater than equal to ab. Then we will get the real roots of x and y, which is mandatory. Now we wish to express this equation, uh, since this single equation represents both the equation, so we wish to represent this general form in in terms of both the equation. So how we will obtain this? Look this, this condition. Now we'll take in this way, by square plus 2h x y plus ax square is equal to 0. Now we'll take the quadratic form of y, and this will represent equation. We know the general form of any equation is equal to y is equal to mx plus c. So since this passes through the origin, so c will be 0. So this type of form we wish to obtain. So how will we get? Now we'll taking y square will be plus 2h by b x y plus a by b x square is equal to 0. Now since it is a quadratic form, it must have a two roots. So if we factorize this, then we will get in such a form that here, if we will take the roots are m1 x and m2 x, because x square and x are in the coefficient of this quadratic form, so we will get in terms of the roots m1 mx, so m1x and m2x are the roots of the equation. Then this will be m1x plus m2x will be minus 2 x by b, is showing that m1 plus m2 will be m1 plus m2 will be m2 will be the relation between the m1 and m2 will be minus 2h by b. What will be the m1 into m2? That just cancelling x square, we will get m1 multiply m2. This will be a by b. Now we have with using this relation, we can formulate the form uh, which is which is representing both the equations m1x. This is the one of the equations, and this is the other equation y minus m2x. Just factorizing the above equation equal to 0. So we have used just roots m1x and m2x, and using the relation m1 plus m2 are related with in this way minus 2h by b, and m1 m2 related with a by b. Then we will get the representation of the equation. Here both the equation are shown. This is the equation of the first equation in first straight line, and this is the equation of the second straight line. Both are passing through the origin. So now if we wish to know the bisector of the two straight lines, is also important. I'm just discussing important parts. One, there are huge topics, but not can be discussed all. So I'm just touching just important one thing. This is straight line passes through the origin. This is one of the straight line between the pair of the straight lines, and this is the another straight line passing through the origin. This is another straight line. So this angle and this straight line makes theta 1 angle, and this straight line makes theta 2 angle. Now we used to know the bisector equation. Bisector means which intersects both the angles. If we this is pi by 6 radian, this is pi by 3 radian, then the bisector angles must be pi by 4. So in this way, means the average of the both the angles is the bisector's angle. So take this is the bisector which passes through between both of the straight lines. So this is theta. Here theta is related to theta 1 and theta 2. How? Theta is 2 theta is equal to theta 1 plus theta 2. So one straight line which is related in such a way with two angles that its twice angle with the x-axis will be the two angles addition. Then this and this and this the straight line must be the intersector of both the angles made by the another straight line. So here this straight line is the bisector angle, and this is the bisector, and we used to know the equation of the bisector. Now this is theta 1, so here m1 will be what? M1 will be tan theta 1, tan theta 1, and its equation will be, since it's passed through the origin, so its equation will be m y minus m1 x equal to 0. Similarly, for this, what will be M2? M2 will be tan theta 2 and Y will be and the equation of Z will be Y minus M2 X equal to 0. Now we wish to know the intersector angle, but we have just only one condition. This is just using this we have to calculate the equation of the bisector. So here theta 1 and theta 2 are related with this equation. So we'll use in this way tan of 2 theta. This will be the tendency. Tan theta actually is the is the tendency of the of this bisector tendency is tan theta. So we wish to know the bisector's tendency. That's why we will take in this way tan theta 1 plus theta 2. This will be tan 2 theta is equal to 2 tan theta one minus tan square theta 1 minus tan square theta, and this will be tan theta 1 plus tan theta 2 1 minus tan theta 1 into tan theta 2. Now we will use this information. Tan theta we will taking m. We will take that intersector tendency is m. M is equal to tan theta. We will put here and deduce the value of m. Then we will easily get the equation of the bisector. So using this, already know the figure and the values. So I am using this. Now we will use the informations we have taken. Here it will be 2m 1 minus m square. Here will be m1 plus m2 1 minus m1 m2. So this will be 2m minus 1 minus m square. We know the general equation of the pair of straight lines passing through the origin, where m1 plus m2 was we have reduced 2h by b 1 minus m1 multiply m2, we have deduced that it will be a by b. Calculate further. B minus a, or cancelling the negative term, we are writing a minus b and 2h. Now after cancelling 2 we will get h minus hm square is equal to a minus b a. Further arranging, we will get hm square plus a minus b m minus h is equal to 0. Now just calculate. Here it is a form of quadratic equation, so here we will get two values of m, because we know that whenever we will calculate bisectors, every pair of equations have two bisectors. We know this. So how I'm just discussing, if you then you can remember, we are taking two straight lines in such a way. Take, then the bisector must be between here also, and a bisector also remains here, which is uh, perpendicular to the first bisector. Means if theta is the angle of one bisector, then pi by 2 plus theta will be the another bisector angle. That's why we are getting two tendency. We will evaluate two tendency also. Here m equal to minus a minus b. I am writing b minus a bracket plus minus, we are writing b minus a whole square, b minus a whole square minus plus 4 h square, 4 h square by 2h. So here for we are getting a for being positive, and we for getting real and positive roots, we need this discriminant should be greater than or equal to 0. So and the bisectors cannot be equal, so it must be greater than 0. Discriminant, both the uh, I- both the bisector must be different, so it must be strictly must be greater than the discriminant strictly must be greater than 0. So here we are getting a condition, and we are taking this discriminant is strictly greater than 0. There the roots are we will obtain will be positive and different. So real and different. Now the equation we will reduce. What will be the equation of that bisector? Will be equation will be y minus mx is equal to 0. But here, if we wish to deduce the pair of the bisectors, so if this is mandatory to deduce the pair of the bisectors, because we have two bisectors of any pair of straight line. So it will be better to write down in this way. Take this are m, one root are m and the other is m prime. One is m and other is m prime. Then we have to calculate the general form. We need to multiply 8 m plus m prime. This will be so m plus m prime. If we will 8, then this will be b minus a by h. You can very simply get this. One addition if you take this m, and if you take minus, then this will be m prime. We will edit both of them, and m multiply m prime will be that this will be here it will be 4h square. Here it will be b minus a whole square minus b minus a whole square and minus 4h square. So we are getting minus 1. So the general equation of the bisectors will be the quadratic form will be y square minus m plus m prime x y plus m m prime x square. This is the general equation of the bisectors. Now we replace and we will get the equation of the bisectors. This will be y square minus b minus a by a xy minus x square is equal to 0. Further, we will summarize it. y square minus b minus a xy minus bx square equal to 0. This is the general form of the uh, pair of the bisectors of any pair of straight line passing through the origin. So I hope you like this video. Thanks for watching. I am continuing discussing analytic geometry of two-dimensional, and I have completed the straight line. And another video will be on circles and other topics of analytic geometry of two-dimensional. Thanks for watching, and please subscribe this channel to get first all the videos. So subscribe this channel, and of course share with your friends, and please comment me in my comment box in YouTube.